Okay, guys. Hey, if my camera decides to glitch a little bit, I'm using my cell phone, so it might fall. If it falls, hopefully I can cut it out. It's nice. Okay, so today we're going to do a fun little experiment with baking soda and vinegar. Now, I'm sure you've all seen this before, the baking soda volcano. Well, you can actually go further in detail with it. It basically is an endothermic reaction that is you can use this to uh, teach your students or just learn for fun, like me, law of conservation of mass for when you have one substance with a reactant and to get the difference of the new product, which is basically just a different form of the substance, the first substance. So before we get any further into the science of it, which is not going to be really explained in this, but I mean it's there. You're going to need a couple materials. You're going to need balloons, baking soda, and the number one ingredient, vinegar. It also helps to have a little bottle just to pour the excess in. You can see I've done it quite a bit of times, but it helps. You're going to need a couple funnels, one for baking powder, the other for vinegar because they are very reactive. Okay. Depends on the beaker. I use small beakers because they're just really easy and really cheap too. I have a couple clear ones, two of these, or two of those, and then a clear one, not a couple. And we'll go ahead and do some more materials to make the reaction. These ones are weird, so it helps to have rubber bands to tie them on. Okay. So this is where it's going to be fun. Okay, we're back. Sorry, I had to move it. You won't see me very well, but I'll occasionally lean forward. Hopefully, some visual sights will be made. Okay, let's just clean up my area up here. I had to move some stuff around to better situate everything. We'll go ahead and start with one of these. You may not be able to see the reaction, but you'll see the product, the end product. This is a little cup of water, just so I can, if stuff gets bad, I had made a couple messes, and it's pretty annoying. So I'm going to open my towel here, make everything a little neater, or cleaner, I should say. Okay, start with the liquid beaker, or funnel. Oh, that fell over. Normally you map out, or you weigh, using your kilograms and grams, how much baking soda and vinegar you're to put in. I've done this quite a bit of time, so we're going to go by eye. We're going to put in roughly 2 kilograms. Milligrams. Yeah, I said roughly, right? Okay, good. Okay, now that's all situated. This is weird. We're going to set him to the side. Okay, take a balloon. Don't matter what color. If you have random balloons, it's okay. Helps to just stretch it out a little bit. Get it used to being wear and tear. Because it's going to expand. But it won't pop. Trust me. Okay, once we do all this, fit that balloon right in the hole of the balloon right in on top of that funnel you've made here. Okay, then you just sprinkle your baking powder right in there. Now this is where you get to have fun. It does not matter how much baking soda you use. I promise. I've used a bunch. The balloon still doesn't do anything important. Alright, got a little feedback here. A little bit more. Okay, well, yeah, we'll call it that. Okay, we can set him to the side. Bring back your beaker. Beaker, base, doesn't really matter. They're the same thing. Okay. Now if you see here, we're going to stretch him over that. Make sure it's nice and secure, but don't pull it up just yet, because that's your fun. Okay. Now here's the science part of this. Before, how I said when pouring the vinegar, to weigh your vinegar and bottle. You should also do that with a balloon, an empty balloon. Say the one you're going to use. Mass it, and then pour your baking powder, the baking soda in. Okay? Hit the scale to 0 with the empty balloon on. No, with the balloon separate. Then pour your baking soda, and then wait again. Subtract the mass of the balloon. Shouldn't be that much. Okay? Now that we're ready, we're just going to take a balloon full of baking soda and pour it right into that solution. Now let's see how we can get this thing going. Now if you're doing this for the first time, you will notice the balloon gets a little cold. And that's due to endothermic reactions. The heat is actually inside and released rather quickly, so it's cold. Okay, this is a very good side. One way to make sure the reactant is done is give it a little shake and make sure all the bubbles are good. Make sure all that baking soda get mixed up and the vinegar's all good. Okay. And you're gonna twist your balloon off. Twist, don't pull, because you will release the gases. Okay, then just slip it off. See, that might happen. You will get a little vinegary on you. And there's a little bit of the excess baking soda and vinegar compound. A little gooey mix that this is a side product of. Well, not really side product, the actual main ingredient, that is sodium bicarbonate right there, but that's my chemistry talking. Okay, now if you notice, see is the discoloration. Hopefully you can see some of the baking soda mixed into the balloon with vinegar, and it made the material that's this stuff as well. It's kind of clammy and clayey. It's okay. If that happens, it's called experimental error, so you'll be fine. You take this balloon, put it right on your scale, and you mass it. Now, if you notice right there how I dropped it, and of course there are some clumps in there and everything. There's actually a rock in there. Yeah, clump of baking powder, baking soda. So, this is going to be very heavy, but that's experimental error. My point. The carbon dioxide that's released during the reaction is heavier than air. I mean, not on top of the balloon and the weight inside. Sorry. It is still heavier, and that's why it falls. Okay, well, this is a fun little thing, and if you do it right, you won't get the clumps. I'm doing mine after a long day. Oh, that's a big old clump. Oh, yeah. Well, so it's still the same situation. Everything was thought out, planned, and we have a very good toy. Now, you're thinking, okay, the balloon will last forever. No. Balloons are still fibrous material, even though they're technically elastic or rubbery. They're microscopic pores, submicroscopic if you would, not saying the name, and eventually the balloon will deflate. I mean, you've all seen a balloon after a party. You get that drooping, almost like the grandpa stuff just hanging there. It's wrinkly and everything. It's nasty. It will deflate. Okay, once you're done here, make sure you clean up all your messes. You use a dry cloth to clean off this, a separate dry cloth to clean off your wet beaker, your wet funnel. This, ask your professor or your teacher what to do. Some of them will ask you just to simply throw it away, depending on if they're using a glass beaker. If it's a big enough beaker, you can use your brush and clean inside. These cost me like 50 cents. I'm probably going to rinse it out and or just throw it away. But it depends on your teacher. Okay? Now, I'm going to set this guy to the side. Get the glass beaker, that way everyone can see everything happen. And we're going to do some gloves. Now, I've done the glove once before, and I got it pretty good. So let's see if we can duplicate that. Okay, yeah, about another half full bottle right there. I don't remember the exact number I said earlier, but that's still the same thing. Okay, and just so we can see a little clearer, we're going to use a light colored balloon. That way we can see inside of it with the light I have coming. Okay, take your powder funnel. Oh, if I don't drop the balloon. Go, guys. Alright. We take everything, make it a little easier to open, and pour it in. One thing about a funnel is you can pour everything on the outside. Oh, let me get down there. Everything on the outside. Get as much as you want in there, and literally tap it close. Oh no! that sometimes will happen, guys. That's why we're underneath a. That's why we have a towel. It's only, don't worry, it's only baking soda. Maybe I'll show you another little fun trick I learned. Balloon got stuck. Alright. So we'll just separate him to the side. He's not really important no more. Fold him up, that way he's not going to interfere. I'll clean him up later. Always report spills to your chemistry teacher. Never leave something hidden and have someone else find it, because if it's a bad accident, it can lead to some serious trouble, guys. You do not want to have to worry about that. And don't worry, if you get baking soda on your hands, it's not going to hurt you. Same with the vinegar. Vinegar is a cooking ingredient. Baking soda, pure baking soda, is here for mold and spores. It does not do anything to your skin. But always use word for your chemistry professor. If your instructor says for you to use gloves, you must put your gloves and safety protection on. Okay? Now we'll get in a little closer, that way you can see this reaction hit. What's going to happen is that baking soda is going to pour right in there. Now as you notice, the gas is hit before all that baking soda poured in. Once the baking soda is pouring in everything, you can just give it a little shake here and there. The reaction is happening underway right before our very eyes. Now if you can see, those little bubbles, well, massive bubbles now, are carbon dioxide being released. The chemical formula, which I've put in one of my earlier videos, probably will repost just to be on the safe side. Everything. Okay? See that stuff right there? Guess what that is? You're right. That is vinegar. Now that slump that just fell in there, that's all the baking soda. Baking soda has taken up some moisture from the the vinegar. Baking soda has taken up moisture from the vinegar, and it has clumped together. Easy way to solve that: just pour everything in that balloon, give it a nice big old shake, and do that right in there. Now you see the reaction kind of started back up. It's because the oxygen and carbon dioxide inside this and the fresh baking soda react to everything. Okay, guys, I'm gonna leave you off at that. Get back over to me. Now I'm hoping this thing recorded, and I'm hoping you all saw everything I'm trying to explain. Chemistry is everywhere, guys. It isn't something this so simple and fun. You can do this with anything. I recommend trying different products, don't go stronger acids, because if you get stronger acids, you have to use more protection, and you can get harmed that way. So I'll end off here, guys. Hope you all have a good day, okay?